Namaste, Vanakkam. Welcome back to Midha Guru. It's me Manan, the maths teacher here. So today in this video lesson, we are going to cover the textbook exercises from Salina Concise Mathematics for the chapter Quadratic Equations. In this video lesson, we will be covering exercises 5a, 5b and 5c, that is on the basics of quadratic equations, the nature of their roots and solving quadratic equation to find roots by the method of factorization. So please watch the video till the end. Also, if you haven't watched the basic concept video of quadratic equations, go to our channel in the description below, subscribe and watch that video. Apart from that, watch all the other videos of SST, English, Maths, Science as well. So let's begin our lesson right now. So let's begin with exercise 5a. In the first question, it tells us to find which of the following are quadratic. How can we check whether an equation is quadratic or not? If you remember, we learned about the standard form. We said that the equation necessarily not exist in the standard form, but if it can be expressed, we can call it a quadratic equation. Let's try. This one here says 3x minus 1 whole square is equal to 5x plus 8. So when we expand, we get 3x squared, which will be 9x squared, plus 1 minus 6x is equal to 5x plus, and I open this bracket as well, it becomes 5x plus 40. Then I'll take all to the to just one side. I'll get 9x square plus 1 minus 6x minus 5x minus 40 is equal to 0. Then I get 9x square minus 11x minus 39 is equal to 0. We see that it is of the form ax square plus bx plus c, where a is 9, b is minus 11 and c is minus 39. So we can say that this is a quadratic equation. Now we come to the next. It says 5x square minus 8x is equal to so as. Let's try and open this bracket as well. We get 5x square minus 8x is equal to 3 into 7, which is 21, minus 3 into 2, which is 6x. Again we bring it to one side, we get 5x squared minus 8x plus 6x minus 21, which can be written as 5x squared minus 2x minus 21 is equal to 0. So again we see it is of the form ax square plus bx plus c. So this is also a quadratic equation. Now let's see the last one. It has brackets on both sides which we have to multiply. So let's start. So x into 3x will be 3x squared, x into 1 will be x minus 12x minus 4. And on this side we get 3x squared plus 6x minus x minus 2. Here in the first step itself, we will see that 3x square, the positive 3x square, is on both sides, which means by classic algebra we can cancel both of them out. So now when we see the rest, we don't even need to solve it. We'll see that there is no x squared term left over in the equation. So this equation cannot classify as a quadratic because it does not have ax squared. Okay. Now we come to the next question. It is x squared plus 5x minus 5 is equal to this. Let's see. X squared plus 5x minus 5 is equal to x squared plus 9 minus 6x. Again, we see that x squared and x squared can be cancelled out. So now we don't have the x squared term in the equation. So this is not a quadratic equation as well. Now we go to the next problem. We get 7x cubed minus 2x square plus 10 is equal to, if we expand that, we get 4x squared plus 5 squared 25, 20x. If we write all of them down on one end, we get 7x cubed minus 2 minus 4 minus 6x squared minus 20x minus 15 is equal to 0. Here we see that the highest power of the variable is 3. So this becomes a cubic equation and it is not a quadratic equation. So now we'll see the last one. It says x minus 1 whole square. So x squared plus 1 minus 2x plus x squared plus 4 plus 4x plus 3x plus 3. So we'll get 2x squared minus 5x . So we got the equation 2x squared minus 5x plus 8 is equal to 0. which is also the standard form of a quadratic equation, that is ax square plus bx plus c. So we can say that this one is a quadratic equation as well. So if you are ever told to check if a given equation is quadratic or not, if it is not solved, that is not simplified, first we simplify it and then we see if we can represent it in the form of the standard form. If we can, it is a quadratic equation. Okay. Now moving on to the next question. It says we have to test whether x is equal to 5 is a solution of the equation x square minus 2x minus 15. Now to check whether it's a solution or not, if you don't remember or you haven't watched the video yet, quadratic equations, the chapter, the concepts and the methods to solve it is out on our channel Midha Guru. So please go to the link in the description and watch that video before you come to this video. Okay, let's get back to it. So it's given that x is equal to 5, we have to check whether it's a solution or not. So we'll just, in place of x, we'll just put the value of 5. So x squared, which means 5 squared minus 2 into 5 minus 15. This is the left hand side. The right hand side is equal to 0, right? We'll solve this and see what happens. It's 25 minus 10 minus 15, which becomes 25 minus 25, which is equal to 0. So the LHS is equal to the RHS. Hence we can say that x is equal to 5 is a solution for the given quadratic equation. Similarly, the next question says to check whether x minus x is equal to minus 3 is a solution of the equation 2x squared minus 7x plus 9. Again, we'll just put the value of x that is given as minus 3 anywhere we see x in this equation. So the left hand side will become 2 into minus 3 whole squared minus 7 into minus 3 plus 9. And the RHS is equal to 0. Solving it, we get 2 into 9 plus 7 into 3, because this minus and this minus get cancelled, and plus 9. We get 18 plus 27 plus 9, which will be equal to 54. Now the LHS is not equal to the RHS. So here when it was equal, we could say it is a solution. And here, because LHS is not equal to RHS, we can say that it is not a solution. Okay, got it? So now moving on to the next question. It says that if root 2 by 3 is a solution of the given equation, find the value of m. So earlier we had to check whether the given value of x was a solution in fact or not. Here it is given to us that this is a solution and there is another variable in the equation, that is m. We are supposed to find that. But the process is basically the same. We say that if x is equal to root 2 by 3, we just substitute it in this equation. The RHS again is 0. Now from the LHS we will get 3 into root 2 by 3 plus 2. It will be equal to 3 into 2 by 3, because root 2 by 3, under root 2 by 3 whole square will be 2 by 3. We cancel this. Then we get root 2 m by root 3 plus 2 is equal to 0. Then we can go about solving this. We get 2 root 3 plus root 2m plus 2 root 3 is equal to 0. Then we can say that m is equal to minus 4 root 3 by root 2, which can be written as, if you can write 4 2 into root 2 into root 2 to root 3, this is a minus, I'm sorry, by root 2, we cancel this out, and then we get that m is equal to 2 root 6. So basically we use the idea that this is a solution in this question, and we equated that the LHS and RHS in this case should be equal. We are not finding out whether they are equal, they should be equal, and from that we calculated the value of m, that would be minus 2 root 6. Okay. Moving on to the next question, it says that both of these are solutions for our given equation, and now the equation has two variables. So when I substitute the first value and then when I substitute the second value, I'll be getting two equations in m and n, and then we'll solve them simultaneously. Okay, let us see. First time I'll take x is equal to 2 by 3. So I'll get m into 2 by 3 whole squared plus n into 2 by 3 plus 6 is equal to 0. So m to 4 by 9 plus n into 2 by 3 plus 6 is equal to 0. Then we'll get 4m, and we'll take the LCM as 9, then 6n plus 9 into 54 is equal to 0. So we got that 4m plus 6n plus 54 is equal to 0. This is the first equation. Second time I'll take that x is equal to 1. Now we get m into 1 squared plus n into 1 plus 6 is equal to 0. We get that m plus n plus 6 is equal to 0. We have 4m here, so what we will do is we'll multiply 2 by into 4. So we'll get 4m plus 6n plus 54 is equal to 0 minus, so I'll be doing 1 minus 4 times of the second equation, right? So I'm getting m plus n plus 6, so it will be 4m plus 4n plus 24 is equal to 0. Now all these will become minus. 4m gets cancelled out, we get 2n plus 30 is equal to 0. So n will be equal to minus 15. Now I'll just substitute this value in this equation. Then I'll get that m minus 15 plus 6 is equal to 0. Which means m minus 9 is equal to 0. So m will be equal to 9. So again, using the logic that if we have solutions, they should satisfy this given equation, we calculated the value of the two variables m and n. So the next question, it's again the 3n minus 3 are solutions of this equation, and we are supposed to find the values of a and b. Again we do the same thing. The first time we take x is equal to 3. Then we write it a into 3 squared plus b into 3 minus 9 is equal to 0. We get 9a squared plus 3b minus 9 is equal to 0. If we take 3 common out from this, we can get 3a squared plus b minus 3 is equal to 0. Oh sorry, I've been writing a squared down. That's not the case. My mistake. It's 3 squared. Anyways, this is the first equation when we used 3 as a solution. Now when we take x is equal to minus 3, we get a into minus 3 whole squared plus b into minus 3 minus 9 is equal to 0. Again this becomes 9a squared, this becomes minus 3b and minus 9. Again, if we take out 3 common, we get 3a squared minus b minus 3 is equal to 0. Now what I'll do is, I'll subtract, again I wrote a squared, I'm so sorry. It's 9a, and then when we take out 3 common, it's 3a. So now I'll be solving both these equations simultaneously. I'll write 3a plus b minus 3 is equal to 0. 3a minus b minus 3 is equal to 0. If I add them, b gets cancelled out, we get 6a minus 6 is equal to 0. So a is equal to 1. Now we substitute a's value in any of the two equations. I'll substitute it in this one. Then I'll get that 3 minus b minus 3 is equal to 0. Which means minus b is equal to 0. So b is also equal to 0. So this is how we can solve questions that are based on the solutions or the roots. So we'll substitute those values in the given equation and we'll go about the process as we are supposed to. So now we will be looking at exercise 5b. This exercise deals with the knowledge of the nature of roots. That is, understanding what is the nature of roots based off the discriminant. Okay, so the first question says, without solving, comment upon the nature of the roots of each of the following. So now the first equation is 7x square minus 9x plus 2. So from this, we'll say that a is equal to 7, b is equal to minus 9, and c is equal to 2. Now we'll calculate the determinant. It will come to b square, that will be 81, minus 4 times of 7 into 2. So it will be 81 minus. So we see that the discriminant is a real number, that is a positive real number. So we can say that the roots of this very equation will be real but unequal, right? Okay. Coming to the second one, the equation is 6x square minus 13x plus 4. From here we see that a is equal to 6, b is equal to minus 13, and c is equal to 4. Again we go about by calculating the determinant. We get b squared, which will be 169, minus 4 times of 6 into 4. 6 4 are 24 and 2 will be 2. So again we have the discriminant as a positive real number, and hence the roots of this very equation will also be real but unequal. Coming to the third one, it is 25x square minus 10x plus 1. Again we get that a is 25, b is 10, and c is 1. Now we will calculate the discriminant, which is b square minus 4ac. So the discriminant will be, b is minus 10 here, I'm sorry. So b squared, which will be 100 minus 4 times of a into c. 4 times of a into c. If the discriminant is equal to 100 minus 100, which is 0. And if the discriminant is 0, we know that the roots will be real and they will be equal. Okay. Coming to the next question, it is x square plus 2 root 3x minus 9 is equal to 0. So a here is 1, b is 2 root 3, and c is minus 9. Now d is b square minus 4ac. So b squared will be 12 minus 1 into minus 9. Shall be d is equal to 12, and this minus gets cancelled, it's plus 9. So this becomes d is equal to 21. Again we have a positive real number for the discriminant. So we can say that the roots of this equation are going to be real and unequal. In the next equation it says x square minus ax minus b square. So here a is equal to 1, b is equal to minus a, and c is equal to minus b squared. Okay. Now we calculate the determinant, the discriminant, and minus a whole squared will be a square minus 4 times of 1 into minus b squared. Get a square plus 4b square. And since we don't know the values of a and b, we will just take that they are positive real numbers. So the roots of this equation will also be real and unequal. And the last one is 2x square plus 8x plus 9. So a here will be 2, b will be 8, and c will be 9. Again we calculate the discriminant. We get b squared, which is 64, minus 4 into ac. Here in this case, we got the discriminant, a negative real number. So we know that the roots of this equation will be imaginary because the square root of the discriminant is impossible to find. Okay, so let's move on to the next question. Now in this next question, unlike the earlier, in this it says that these equations have equal roots. They are just stating right away that these two equations have equal roots, which means the discriminant of both these equations should be 0. Now in the mix of a, b and c, there is a variable p. In this equation it is in b, and in this equation it is in c. So based on the fact that the discriminant is going to be 0 because these equations have equal roots, we have to find the value of this variable p in both these equations. So we begin with this one. Read the equation carefully. It says 4x square minus p minus 2 x plus 1 is equal to 0. So, a is equal to 4, b is equal to minus p minus 2 and c is equal to 1. So now we know that the discriminant is b square minus 4ac and in this case it is 0. So we go about that b squared, which means p minus 2 whole squared, because minus p minus 2 whole square will also be the same. So p minus 2 whole squared minus 4 into 1, because a into c is equal to 0. So we get p squared plus 4 minus 4p minus 16 is equal to 0, which is p squared minus 4p minus 12 is equal to 0. So we'll solve this by factorization. So 6p minus 2p plus 2p minus 12 is equal to 0. So p minus 6 plus 2, p minus 6. So p plus 2 into p minus 6 is equal to 0. So p is either minus 2 or p is 6. So when it is given to you that this equation has equal roots, what you are supposed to decipher is that the discriminant is going to be 0. Only in that case are the roots real and equal. From that we have to calculate the value of this variable that will be present in the equation. Here it formed a quadratic itself. So again we solved it to get p is equal to minus 2 or p is equal to 6. Now coming to this next equation, here a is equal to 1, b is p minus 3 and c is p. So now we go about that. D is b square minus 4ac and here it will be 0. So we get b square minus 4ac. So b squared will be p minus 3 whole squared minus 4 into 1 into p. You get p squared minus plus 9 minus 6p minus 4p equal to 0. It will be p squared minus 10p plus 9 is equal to 0. Solve this as p square minus 9p minus p plus 9 is equal to 0. Get p minus 9 minus 1 p minus 9, which means that p minus 9 into p minus 1 is equal to 0. So in this case p is either 9 or p is equal to 1. So this is how, when you are given the condition that the following equation have equal roots, this is how we are supposed to apply the knowledge of the discriminant to find the variable present in that is the second variable, the unknown variable in this equation. Okay, let's move on to the next question. So again this says that if this equation has equal roots, find the value of n. N is the variable here. So the logic is pretty much the same. So from this equation, which is 3x squared minus 12x plus n minus 5, we get that a is 3, b is minus 12 and c is n minus 5. If the equation has equal roots, it means that the discriminant is going to be 0, right? So we'll say b square minus 4ac, which is minus 12 squared minus 4 into 3 into n minus 5, a into c. This should be equal to 0. So minus 12 squared will be 144 minus 4 into 3n minus 50, which will become 144 minus 12n minus 60 is equal to 0. So we take 12n to the other side, we get 12n is equal to 84. So n will be equal to 84 by 12, which is 7. So again, given the fact that an equation has equal roots, we can apply that the discriminant is 0 and from there substitute the values of a, b and c to the discriminant and find out the other variable in the equation that we are supposed to find. Now in this next question again, it says that we are supposed to find the values of m if the following equation has equal roots. Again we go about it the same way, that a is m minus 2, b is m plus 5 and c is 16. Now if the equation has equal roots, the discriminant is going to be 0, right? So we'll do b squared, which will be m plus 5 whole squared minus 4 into a into c, it should be equal to 0. So we'll write this equation down. It will be n square plus 25m. 25. I'll just erase that. I'm sorry. Okay. 25 plus 10m minus 4 into 16m minus 32. 25 plus 10m minus 4 into 16 will be 64m, and 4 into 32 will be, as minus minus will become plus 128 is equal to 0. So we get m squared minus 54m plus 153 is equal to 0. Now we are supposed to solve this equation to get the values of m. So we'll do m squared let's write it down clearly. So I split the middle term, that is minus 54m into minus 51 and minus 3. Now I'll do m and I'll get m minus 51, and then I'll take minus 3 as common, I'll get m minus 51. So from this we get that m minus 3 into m minus 51 is equal to 0. So either m is equal to 3 or m is equal to 51. Okay, so let's look at the next question once. So the next question says find the value of k for which the equation has, in this case it says distinct and real roots. Distinct meaning different. So here the discriminant won't be 0. It will be greater than 0. Very good. So if this has distinct and equal real roots, we will say that the discriminant is greater than 0. So as it's clear from this, we don't have to find one value, we have to find a range of values for which k could be k could have for this equation to have distinct and real roots. So from this I'm going to write b squared, which is minus 6 whole squared, minus 4 times of 3 into k, which should be greater than 0. So I get 36 minus 12k should be greater than 0. Then if I take 12k to the other side, I get 36 is greater than 12k. Then I get 36 by 12, which will be 3. So k should be less than 3. So for any value of k less than 3, this equation is going to have real and distinct roots. Okay. Now let's look at the solutions for exercise 5c. In this exercise, we'll be solving equations with the help of the method of factorization. So the first 20 questions, we are just supposed to factorize and find the roots. Let's begin, okay? So we have x squared minus 10x minus 24. For factorization, what we have to do is you have to find a substituent value for to write in place of minus 10. That means you have to split it into terms such that it is equal to a into c. That you have to do in our brains or in rough. You don't have to write it down in the equation. And if you don't know how we came about this or how this method is applied, that means you haven't watched Quadratic Equations part 1 yet. So please go down to the link in the description and watch that video. As well as check out our channel Midha Guru, because we have faculties who are quite excellent in their subjects, and you'll find videos to help you with your education well. Okay, let's get back to our exercise. Excuse me. So I have x squared minus 10x minus 24. I'll just write it down again. Now I have to split minus 10 in such a way that its sum is equal to minus 10, obviously, and its product, that is the two, after we get the two terms that we split it into, the product should be equal to, here as nothing is written, it's 1, so 1 into minus 24, which will be minus 24. So minus 12x plus 2x. So what we did is we split minus 10 into minus 12 plus 2. If we add it, we get minus 10 back. And when we multiply minus 12 with plus 2, we get minus 24. After that, we'll take x common here, we'll get x minus 12. And here we'll take 2 common, we'll get again x minus 12. So from here we'll write x plus 2 into x minus 12 is equal to 0. After this, we apply the zero product rule. That is, if x plus 2 into x minus 12 is equal to 0, then either x plus 2 is equal to 0 or x minus 12 is equal to 0. So x is either equal to minus 2 or x is equal to 12. So this is how, by using factorization, we can solve equations to get their roots. Okay. Excuse me. Okay. The next equation says x square minus 16 is equal to 0. So here the factorization can be a little bit different if I want. Let's see, it is x square minus 16 is equal to 0. So x square minus 16, which is 4 squared, is equal to 0. Now this is of the form a square minus b square, and we know that can be factorized as a plus b, in which a is x and b is 4, and into a minus b. So now again we came back that it is a product of two binomials. So now applying the zero product rule, we will get that x is either equal to plus 4 or x is equal to, x plus 4 is equal to 0 or x minus 4 is equal to 0, from which we will deduce that x is either equal to minus 4 or x is equal to plus 4. There is another way to solve such problems in which the x term, that is the middle term itself, is missing, or we can directly, instead of doing this, we can do x square is equal to 16 and simply apply square root on both sides. You get x is equal to root of 16, which will be equal to plus or minus 4, which is very much the same values that we got as well. So such questions we can solve either this way or in that. Okay. Moving on to the next question, it says 2x square minus 1 by 2x is equal to 0. Here what we are going to do is we are going to take x common. Let's see what I'm going to do is, first I'll just write down the equation. It is 2x square minus 1 by 2x is equal to 0. See, just remember that it is a method of factorization. It's not necessarily every time that we have to split the middle term itself. Sometimes it may vary a bit. So here what we are going to do, the only thing common in both the terms is x. So we'll take that 2x minus, if I take x common, we get 2x and minus 1 by 2. Now here also it is a product of two polynomials. See, two parts, that is x into 2x minus 1 by 2. So from this we will get that either x is equal to 0 or 2x minus 1 by 2 is equal to 0. So x is 0 itself is a value, and from this we will get that x is equal to 1 by 2 into 2. So x will be equal to 1 by 4. So these will be the values for x for the given equation. Now the next equation is x into x minus 5 is equal to 24. So we'll solve this by writing the equation first. We multiply x and x is x square minus 5x is equal to 24, and then we'll bring 24 to this side. We'll get x square minus 5x minus 24 is equal to 0. Now we have to solve this equation such that we'll get, I have to split minus 5 such that the addition should be equal to minus 5 and the multiplication, the product should be equal to minus 24. So I'll write x square minus 8x plus 3x minus 24 is equal to 0. See, I split minus 5 into minus 8 and 3. That way when I add it, I get minus 5, and when I multiply it, I get 1 into minus 24, that is minus 24. So I take x common, I get x minus 8. Here I take 3 common, again I get x minus 8, which is equal to 0. So then I group them together, x plus 3 into x minus 8 is equal to 0, which means that either x plus 3 is equal to 0 or x minus 8 is equal to 0. So x will be equal to minus 3 or x will be equal to 8. Okay, let's move on to the next equation. Next equation says 9 by 2x is equal to 5 plus x squared. We'll write it down just a bit differently. Plus 5 is equal to 9 by 2. So if we take the LCM as 2, we'll get 2x squared minus 9x plus 10 is equal to 0. And taking 2 to the other side, we'll get 2x squared minus 9x plus 10 is equal to 0. Now I have to split minus 9 in such a way that its sum is equal to minus 9 and its product is equal to 2 into 10, that is 20. So what I'll do is I'll write 2x squared minus 4x minus 5x minus 10 is equal to 0. So I split minus 9 into minus 4 and minus 5. When I add them, I get minus 9. And when I multiply them, I get, 10 into 2, that is 20. So I take 2x common here, I get x minus 2. And here I take 5 common, I get x minus 2. So then I'll group it as 2x minus 5 is into x minus 2 is equal to 0. Again applying the 0 product rule, either 2x minus 5 is equal to 0 or x minus 2 is equal to 0, which implies that x is equal to 5 by 2 or x is equal to 2. Getting a hang of it? We'll see a few more problems one by one. So the next question is 6 by x is equal to 1 plus x. So the first thing that we'll do is we'll bring this 6 by x to one side of the equation. We'll get x plus 1 minus 6 by x is equal to 0. Now for this entire equation, I'll take x as the LCM of the denominators. So I'll get x squared plus x minus 6 is equal to 0. So my equation will be x squared plus x minus 6 is equal to 0. Because x goes to the other side, it gets multiplied to 0, it's equal to 0 itself. So now I have to split 1x as there is nothing in front. It's not 0, it's 1x. So I have to split 1x in such a way that the sum is equal to 1, obviously, and the product is equal to 1 into minus 6, that is minus 6. So I'll write x squared plus 3x minus 2x minus 6 is equal to 0. I'll take x as common, I'll get x plus 3, minus 2 as common, I'll get x plus 3. I can say that x plus 3 into x minus 2 is equal to 0. So either x plus 3 is equal to 0 or x minus 2 is equal to 0. So either x is equal to minus 3 or x is equal to 2. These are the solutions for the given equation. The next question is x is equal to 3x plus 1 by 4x. So first I'll take this 4x to the other side. So x into 4x is equal to 3x plus 1, which I'll write as 4x square is equal to 3x plus 1. Then when I bring them to the same side, I'll get 4x squared minus 3x minus 1 is equal to 0. Now again I have to split minus 3 in such a way, sum of both the terms should be minus 3 and the product should be 4 into minus 1, that is minus 4. So 4x squared minus 4x plus x minus 1 is equal to 0. Here I'll take 4x as common, I'll get x minus 1, then I'll take 1 as common, I'll get x minus 1. So 4x plus 1 into x minus 1 is equal to 0. So either 4x plus 1 is equal to 0 or x minus 1 is equal to 0. So x will become minus 1 by 4 or x will be equal to 1. These are the solutions for the given equation. Now the next question is x plus 1 by x is equal to 2.5. So bringing all the terms to one side, I'll get x plus 1 by x by 2.5 minus 2.5 is equal to 0. So again I'll take the denominators of these fractions as x, the LCM of the denominators as x. So I'll get x squared plus 1 minus 2.5x is equal to 0, which is x squared minus 2.5x plus 1 is equal to 0. I'll multiply this equation by 2. I'll get 2x squared minus 5x plus 2 is equal to 0. Now I have to split minus 5 into two terms such that their sum is equal to minus 5 and the product is equal to 2 into 2, that is 4. So I'll write 2x squared minus 4x minus x plus 2 is equal to 0. So when I add minus 4 and minus x, minus 4x and minus x, I'll get minus 5x, and when I multiply minus 4 by minus 1, I'll get 4. So I'll take 2x as common here, I'll get x minus 2 minus 2. If I write minus 1, I get x minus 2. So 2x minus 1, x minus 2 is equal to 0. So either 2x minus 1 is equal to 0 or x minus 2 is equal to 0. So x will either be equal to 1 by 2 or x will be equal to 2. Okay. Moving on to the next question, we have 2x minus 3 whole square is equal to excuse me, 49. So when I expand this in the form of a minus b whole square, I'll get, it won't be 2x, that is, this will be 2x whole square, that is 4x square plus 9 minus 12. 12x is equal to 49. If I bring 49 to the other side, it becomes 4x square minus 12x plus 9 minus 49 is minus 40. And then I'll divide this equation by 4 because all of the terms are divisible by 4. I'll get x squared minus 3 minus 10 is equal to 0. Sorry, 3x. I'm so sorry. Now I have to split minus 3 in such a way that its sum is equal to, the sum is equal to minus 3 and the product is equal to 1 into minus 10, that is minus 10. So I'll say x square minus 5x is x plus 2x minus 10 is equal to 0. So I'll take x common as x minus 5 and I'll take 2s common and then x minus 5. Then I'll write x plus 2 into x minus 5 is equal to 0. So either x plus 2 is equal to 0 or x minus 5 is equal to 0. So x is either equal to minus 2 or x is equal to 5. Okay. So now moving on to the next question, we have 2 into x squared minus 6 is equal to 3 times x minus 4. What we simply do is we simplify this, that is we open the brackets, we get 2x squared minus 12 is equal to 3x minus 12. See, I have minus 12 on both sides, I cancel them out. Then I bring 3x to the other side, I get 2x squared minus 3x is equal to 0. I'll take x as common because there is nothing else to be taken as common. So I'll get 2x minus 3 is equal to 0. Now we have the product of x into 2x minus 3. So either x is equal to 0 or 2x minus 3 is equal to 0. So x will be equal to 0 or x will be equal to 3 by 2. Okay. Now in this next question, we have the product of binomials on this side and the product of two binomials on this side. So simply what we do is we simplify them. We open the brackets, multiply them, we get 2x squared into 8x, 2x plus 8 equal to, we'll get x squared plus 3x plus 7x plus 21. So if we bring all this to this side, we'll get 2x squared plus 10x plus 8 minus x squared minus 10x minus 21 is equal to 0. Now 10x and 10x get cancelled. We have x squared minus 13 is equal to 0. Now again we can solve this by saying that x squared is equal to 13. So if I place square root on both sides, I get x is equal to root 13, which will be the positive or negative roots of 13. So x will be equal to either positive root of square root of 13 or x will be equal to the negative square root of 13. Okay. So these are the roots for the given equation. Now in the next question, we have to split this middle term. So here we have a plus bx plus ab. So answer will also be in the terms of a and b. That is, the roots will be in the terms of a and b. Here what we'll do is we'll simply open the bracket, then I'll get minus ax minus bx plus ab. What can I take common here? I can only take x. I'll get x minus a. And then I'll take minus b common here. I'll again get x minus a. Right? So now I'll write x minus a into x minus b is equal to 0. Which means either x minus a is equal to 0 or x minus b is equal to 0. Which means x is equal to a or x is equal to b. So these are the roots for our given equation. Now in the next question, I want you to pay special attention that it says x plus 3 whole squared minus 4 into x plus 3 minus 5 is equal to 0. See, there are two ways of solving this particular type of question. Either we can just solve this equation, that is we expand this, we multiply that and we write the final equation as 1 and solve it, or what I am going to do is I'll take x plus 3 as y. Then our new equation is if x plus 3 is y, then it's y squared minus 4y minus 5. That's what I'm going to write. So now the equation is y squared minus 4y minus 5 is equal to 0. Now the middle term here is minus 4y. I have to split it in two terms such that the coefficients add up to minus 4 and they multiply to form minus 5. Excuse me. Minus 5 is equal to 0. Here I take y as common, I get y minus 5. And here I take 1 as common, I get y minus 5 again. So I have y plus 1 into y minus 5. So either y plus 1 is equal to 0 or y minus 5 is equal to 0. So either y is equal to minus 1 or y is equal to 5. This is not the end, however. Now we took x plus 3 to be y. So we'll write that x plus 3 is equal to minus 1 or x plus 3 is equal to 5. Then we'll get that if we take this to the x is equal to minus 4, or I'll take this to the other side, it will be x is equal to 2. These are the roots or solutions for the given quadratic equation. So when we see a group of terms that is similar in both the x squared and x terms, we can take them as another variable, solve that equation because it will be simpler, and then we can substitute our values back. Okay. So the next question is of the similar type. It says 4 into 2x minus 3 whole squared minus 2x minus 3 minus 14 is equal to 0. So if I take 2x minus 3 as a, I will get the equation to be 4a squared minus a minus 14 is equal to 0. So I have to split the coefficient of a, that is 1 minus 1, in such a way that its sum is equal to minus 1 and the product of those coefficients is equal to 4 into minus 14, which will be minus 56. So I'll write 4a square minus 8a plus 7a, which will add up to minus a, and if I multiply minus 8 and plus 7, I get minus 56. So here I'll take 4a as common, I'll get a minus 2, and here I'll take 7 as common, I'll get a minus 2 as well. Then either 4a plus 7 is equal to 0 or a minus 2 is equal to 0. So then I'll get that a is equal to minus 7 by 4 or a is equal to 2. Again, this isn't the end of the problem. Now we have to substitute our value of a back into these equations. So either 2x minus 3 is equal to minus 7 by 4 or 2x minus 3 is equal to 2. So if I solve this, I take to the other side, it becomes minus 7 by 4 plus 3, which will become 2x is equal to minus 7 plus 12. So 2x is equal to 5 by 4. Then x will be equal to 5 by 8. Similarly, 2x minus 3 is equal to 2. So 2x is equal to 5. Then x is equal to 5 by 2. So these will be the roots for the given equation. Moving on to the next question, we have this 3x minus 2 by 2x minus 3 is equal to 3x minus 8 by x plus 4. So simply what we will do is we will take this up here, multiply it to this, and this we will take up here and multiply it to this. So we will get 3x minus 2 into x plus 4 is equal to 3x minus 8 into 2x minus 3. We saw a problem similar to this earlier. We have to simplify this and we have to solve it and get the values. Let's see. So when I multiply on this side, I get 3x squared. This is x and this is 4. Please don't be confused. So 3x squared into minus, we'll get plus will be 12x minus 2x minus 8 is equal to 6x squared minus 9x minus 16x plus 24. So if I take all this to this side, this is 10x, 25x. We have 3x squared minus 25 minus 10 minus 35x. If I take this, becomes 32 is equal to 0. Now I have to split minus 35 into two terms. I split it into, clearly the easiest splitting that I have done. So I write I write x minus 1. Then I take 32 as common. I get x minus 1. So either 3x minus 32 into x minus 1 is equal, x minus 1 is equal to 0. So either 3x minus 32 is equal to 0 or x minus 1 is equal to 0. Then x is equal to 32 by 3 or x is equal to 1. So these will be the solutions for that given equation. Now in the next question, it says 2x square minus 9x plus 10 is 0. We have to solve it. But we have to give a solution in two parts. First, we have to consider when x is only an element of natural numbers. And second, we have to consider when x is an element of rational numbers. Okay. So first things first, what we will do is, we will try and solve that equation. Okay. So we have 2x squared minus 9x plus 10 is equal to 0. So now I have to split minus 9 such that when the two coefficients are added, they give minus 9, and when they are multiplied, they give us 20. So I'll write minus 4x minus 5x plus 10. So minus 4x minus 5x add up to minus 9x, and if I multiply minus 4 and minus 5, I get 20. So then I take 2x common here, get x minus 2, and I take 5 common, I get x minus 2. So 2x minus 5 into x minus 2 is equal to 0. So either 2x minus 5 is equal to 0 or x minus 2 is equal to 0. From this, x is equal to 5 by 2 or x is equal to 2. So we got two values for our equation, one that x is equal to 5 by 2 and the other that x is equal to 2. Now we have to divide our answer such that it falls into these two categories. The first we will see is that x is an element of n, which is natural numbers. So for this equation, particular equation, we have two solutions of x. We have to tell which of these solutions falls under. If both falls, we can write both. But we can see that 5 by 2 is clearly not a natural number, because natural numbers are 0, 1, 2, 3, 4 and so on. I'm sorry, not 0 but 1, 2, 3, 4 and so on. So we'll see that this is the only value that fits the first explanation. So we'll say that when x is an element of n, x is equal to 2. As these are the only two values for the equation and only one fits our criteria. Now the second is when x is a rational number. Now we know rational numbers are any numbers which can be expressed as p by q, and we'll see both of these numbers. If this is 5 by 2, this can be 2 by 1. So both are in fact rational numbers. So when x is an element of rational numbers, we can say that x is equal to 5 by 2 as well as 2. So when it's a natural number, when it says that it's a set of natural numbers, then only the natural number part, that is one of the solutions, came out. And when it's a part of rational numbers, you can see both the solutions are rational. Now this is the next question. So in the next question, we have x minus 3 by x plus 3 plus x plus 3 by x minus 3 is equal to 2.5. Again, there are two ways to solve this. Either we can take the LCM here and form the equation and solve it, or just see it is, just a second, says x minus 3 by x plus 3. I want to take this as y. Why I am doing so is because this becomes 1 by y. As you see, this is just the reciprocal of a term. So 1 by y will be x plus 3 by x minus 3. Now we'll replace these values in our equation. We'll get y plus 1 by y is equal to 5 by 2. Now if we bring all of them together and take y as the LCM, if I bring this, then this becomes, okay, it will become 2y. So we will have 2y squared plus 2 minus 5y is equal to 0. Then 2y square minus 5y plus 2 is equal to 0. Now again I have to split minus 5 such that the two coefficients add up to minus 5 and multiply to form 2 into 4. So I'll write 2y square minus 4y minus y plus 2 is equal to 0. Then I'll take 2y as common, I'll get y minus 2. Then I'll take minus 1 as common, I'll get y minus 2 as well. So then I can write that 2y minus 1 into y minus 2 is equal to 0, which means that y is equal to either 1 by 2 or y is equal to 2. Now we'll substitute these values back. So y was x minus 3 by x plus 3. So either this is equal to 1 by 2 or x minus 3 by x plus 3 is equal to 2. In this case, 2x minus 6, because I multiply it here, is equal to x plus 3. I bring the x to this side and then I get 2x minus x is equal to 6 plus 3, which means x is equal to 9. This I get from when y was equal to 1 by 2. And when y was 2, I will get x minus 3 is equal to 2x plus 6. Now I'll take 6 to this side and x to the other side. I will get 2x minus x is equal to minus 6 minus 3. So x will be equal to minus 9. So the values of x are either 9 or minus 9. Now again I am telling you, I substituted this particular value to be a other variable and then I took its reciprocal as 1 by y. But that's not the only way to solve it. Another way would be if we add these two fractions before transferring this to the other side. We take the LCM as x plus 3 into x minus 3. This becomes x minus 3 whole square. This becomes x plus 3 whole square. That will also be a correct way to solve this equation. Okay, let's move on to the next question. Next question is 4 by x plus 2 minus 1 by x plus 3 is equal to 4 by 2x plus 1. So we will solve this. First, what we will do is in these two fractions, we will take the LCM of the denominators. So we will multiply x plus 3 to 4 and then to 1 we will multiply x plus 2. And here we will write x plus 2 into x plus 3 is equal to 4 by 2x plus 1. Now, this will be equal to 4x plus 12 minus x minus 2. This will be equal to x squared plus 3x plus 2x plus 6 is equal to 4 by 2x plus 1. So when we operate here, we will get 4x minus x, which is 3x plus 10 by x square plus 5x plus 6 is equal to 4 by 2x plus 1. Now that we have arrived here, we will multiply this over here and this to 4. So we will get 3x plus 10 into 2x plus 1 is equal to 4 into x squared plus 5x plus 6. From this we will get 6x squared plus 3x plus 20x plus 10 is equal to 4x squared plus 20x plus 24. So it will be 6x squared plus 23x plus 10 is equal to 4x squared plus 20x plus 24. So we'll bring all the terms to one side of the equation. We'll get 6x squared minus 4x squared, which will be 2x squared, 23 minus 20, which will be 3x, and 10 minus 24, which will be minus 14, is equal to 0. So now we have the quadratic equation 2x squared plus 3x minus 14 is equal to 0. To solve that, we have to split the middle term, that is we have to split 3 such that its sum is equal to 3 and its product is equal to 2 into minus 14, which will be minus 28. So I'll write. So when I multiply plus 7 and minus 4, I get minus 28, and when I add them, I get 3x. So here I can take x as common. I'll get 2x plus 7 and minus 2 as common, then again I'll get 2x plus 7. So we have x minus 2 into 2x plus 7. X minus 2 into 2x plus 7 is equal to 0, from which we can deduce that either x minus 2 is equal to 0 or 2x plus 7 is equal to 0. Sorry. I'm sorry, just a second. Yeah, this is equal to 0. Next, either x is equal to 2 or x is equal to minus 7 by 2. So this will be the solution for the given question. Let's move on to the next question. So the next question says 5 by x minus 2 minus 3 by x plus 6 is equal to 4 by x. Similarly, like the earlier problem, first we will take the LCM of these two denominators. It will be as x minus 2 into x plus 6. 5 multiplied by x plus 6 minus 3 multiplied by x minus 2 is equal to 4 by x. From here I will get 5x plus 30 minus 3x plus 6, because minus and minus will become plus. And down we will have x squared plus 6x minus 2x minus 12 is equal to 4 by x. On simplifying this, you will get 2x plus 36 is equal to x squared plus 4x minus 12 is equal to 4 by x. Now again we will multiply x here and we will multiply this entire term here. So we will get x into 2x plus 36 is equal to 4 into x squared plus 4x minus 12, which in turn will be equal to 2x squared plus 36x is equal to 4x squared plus 16x minus 48. So if we take all the terms to any one side of the equation, we will get 2x squared, because 4 minus 2 will be 2x squared, and we'll take 36, it will become minus 20x minus 48 is equal to 0. Here we can either directly start solving it, or we can take 2 out common, from which we will get 2x squared minus 10x minus 24 is equal to 0. And we'll take 2 to the other side, that will become division, so it will again be 0. So x squared minus 10x minus 24 is equal to 0. So now I have to factorize by splitting 10. Excuse me. So I'll write x squared minus 12x plus 2x minus 24. Take x as common, I get x minus 12. Then I take plus 2 as common, I get x minus 12 again. So it is x plus 2 into x minus 12 is equal to 0. So x will either be equal to minus 2 or x will be equal to 12. So these will be the solutions for that given equation. So in the next question, we have 1 plus 1 by x plus 1 into 1 minus 1 by x minus 1 is equal to 7 by 8. So what we will do is we will multiply 1 and 1, we will get 1. I multiply this, I get 1 by x minus 1. Then I multiply this, I get 1 by x plus 1 into by x minus 1 by 1 plus x plus 1 minus 1 by x square minus 1, because a plus b into a minus b will be a square minus b square. Then I'll get 7 by 8. I'll take 1 to the other side, I will get 1 by x plus 1 minus 1 by x minus 1 minus 1 by x squared minus 1 is equal to 7 by 8 minus 1. Here I can see that the LCM will be x square minus 1, because x square minus 1 we got by multiplying x minus 1 into x plus 1. So I can take the entire LCM as x square minus 1. So here, since there is x plus 1, I have to multiply it by x minus 1. Minus x plus 1 minus 1 is equal to minus 8, we will get minus 1 by 8. Since I multiply, when I take the LCM as 8, this becomes 8, 7 minus 8, 1, 8 is minus 1. Then we will get x minus 1 minus x minus 1 minus 1 by x squared minus 1, I cut off x, is equal to minus 1 by 8, which will be equal to minus 3 by x squared minus 1 is equal to minus 1 by 8. So I cancel that minus. Now I am left with 3 by x square minus 1 is equal to 1 by 8. I multiply 8 here and I multiply x square minus 1 to 1. So I get 24 is equal to x square minus. So x squared will be equal to 25. Now I know that 25 is the square of, I know that 25 is the square of 5. So x will be equal to the root of 5 squared, which in turn will be equal to either plus or minus 5. So x is either equal to 5 or x is equal to minus 5. And that, kids, is the solution for our given equation. Let us see the next question. Now the next type of question says, we are supposed to find a quadratic equation whose solution set is this and this. In this particular type of question, we don't have a quadratic equation. Instead, we have the end product, that is the solutions. And from that we have to solve, or we have to make a quadratic equation. If we move our steps back to how we were studying factorization, we saw that we factorized the quadratic equation to get a product of two binomials, that is single degree binomials, x minus or x plus a into x plus b, which is equal to 0, where a and b will be nothing but solutions. So when I say x plus a is equal to 0, it means x is equal to minus a. So similarly, we'll start by taking reverse steps. So if 3 and 5 is the solution, which means x is equal to 3 or x is equal to 5. So now I take both of them this side, I get either x minus 3 is equal to 0 or x minus 5 is equal to 0. In the next step, I will say that x minus 3 into x minus 5 is equal to 0. Since either of them can be 0, their product should be 0. Then I will multiply the terms. I'll get x squared minus 5x minus 3x plus 15 is equal to 0, which I equate to get x squared minus 8x plus 15 is equal to 0. So for the given solution set, that is 3, 5, we followed the steps to get the quadratic equation, that is x square minus 8x plus 15. And here in the second part, we have to do pretty much the same. So we say that x is equal to minus 2 or x is equal to 3, which implies that x plus 2, since minus comes and becomes plus, x plus 2 is equal to 0 or x minus 3 is equal to 0. So the product should also be 0. So we get x plus 2 into x minus 3 is equal to 0. Again I multiply, I get x squared minus 3x plus 2x minus 6 is equal to 0. Then when I simplify it, I get x squared minus x minus 6 is equal to 0. So for this given solution set, this is my quadratic equation. Okay, let's see the next question. In the next question, we have the equation x by 3 plus 3 by 6 minus x is equal to 2 into 6 plus x by 15. And this is given that x is not equal to 6. This is because if x is equal to 6, this becomes 6 minus 6, which is 0. And 3 divided by 0, or for that matter, anything divided by 0 is undefined. So this equation becomes undefined. For that, x will never be equal to 6. So now let's start solving as we were. So we get x by 3 plus 3 by 6 minus x is equal to 2, 6 plus x by 15. Now here I'll take the LCM. I'll get 3 into 6 minus x. So here I multiply 6 minus x and here I multiply 3, which is equal to 12 plus 2x by 15. Then when I multiply it, I get 6x minus x squared plus 9 by 18 minus 3x is equal to 12 plus 2x by 15. Now I'll just cross multiply 15 here and this entire term here. So I'll get 15 into 6x minus x squared plus 9 is equal to 12 plus 2x into 18 minus 3x. So I get 90x minus 15x squared, 15 into 9 is 35 is equal to 12 into 18, 18 to 180 plus 36, 216 minus 36x plus 36x minus 2 into 6x squared. So this gets cancelled out. Then we'll bring all the terms to any one side of the equation. We get 15x squared minus 6x squared minus 90x plus 216 minus 135. So I'll write the fresh equation here. 15 minus 6 will be 9x squared minus 90x, 216 minus 135, which will be equal to this will be equal to 0. So now either I can start solving right away or I'll just take 9 as common. I'll get x square minus 10x plus 9 is equal to 0. 9 goes there and it becomes 0 in itself. So we have x squared minus 10x plus 9 is equal to 0. Excuse me. So now I have to factorize by splitting this minus 10. So I'll write x square minus 9x minus x plus 9 is equal to 0. Here I take x as common, I get x minus 9, and I take minus 1 as common, I get x minus 9 as well. So either x minus 1 into x minus 9 is equal to 0, which means either x minus 1 is equal to 0 or x minus 9 is equal to 0. Which means x is equal to 1 or x is equal to 9, which is the solutions for this given equation. Let's move on to the next question. The next question is, solve the equation 9x squared plus 3x by 4 plus 2 is equal to 0 if possible for x is an element of real numbers. First thing we have to do is we have to try and see if this equation is solvable. After that, if we get the solutions, we have to see which of these solutions which we get are elements of real numbers. So let's start. So we have 9x squared plus 3x by 4 plus 2 is equal to 0. So instead of splitting this 3 by 4x, I'll just multiply the equation by 4 on both sides. So this will be 0 into 4. Since 0 into 4 is 0, we get 36x squared plus 3x plus 8 is equal to, it's equal to 0. Now, I have to split 3x in such a way that it is equal to the product of 36 into 8. And since both are positive, here we come to a juncture where 36 into 8 is 288. And there is no way that we can split positive 3 into two positive terms whose product is equal to 288. Which means that solving this equation by factorization is not going to be possible. Okay? So we'll move on to the next question. So in the next question, we have find the value of x if a plus 1 is equal to 0 and x square plus ax minus 6 is 0. So don't get confused. What we have to do here is from this given equation a plus 1 is equal to 0, we substitute a value for a. That is, we calculate the value of a and then we substitute it in this equation. So let's start. First it is given that a plus 1 is equal to 0, which means a is equal to minus 1. Right? So I mark this as equation 1. Now x square plus ax minus 6 is equal to 0. Mark this as 2. Substituting 1 into 2. We get x squared. A is minus 1, so this becomes minus x. Minus 6 is equal to 0. Now we can solve this equation by factorization. So I split minus x into minus 3 plus 2x. So we will get x minus 3 plus 2 to x minus 3 is equal to 0. Which implies x plus 2 into x minus 3 is equal to 0. So either x plus 2 is equal to 0 or x minus 3 is equal to 0. Which means x is equal to minus 2 or x is equal to 3. These are the solutions for the given quadratic equation, that is x square plus ax minus 6 is 0. So let's look at the next question once. Next question is also similar, but instead of one equation we have two equations, one for a, one for b, and then our equation deals with both of them. 12x square is equal to ax minus b. So what we will do is, first we will solve for the values of a and b, then we will substitute it into this equation. If a plus 7 is given as 0, this implies a is equal to minus 7. And if b plus 10 is given as 0, which means b is equal to minus 10. Now substitute the values of a and b that I found out in this equation. Given 12x square is equal to ax minus b. So I'll get 12x square is equal to, instead of a I write minus 7x, and instead of b I write minus 10, but since this sign is minus, it becomes plus 10. Now I bring all of them to one side, I get 12x squared plus 7x minus 10 is equal to 0. So now I have to split 7x such that its sum is equal to 7 and the product of the coefficients is equal to minus 120. So I split it into 15x minus 8x. We add that, we get 7x. And when I multiply 15 into 8 minus 8, I get minus 120. So I take 3x as common, I get 4x plus 5. And I take minus 2 as common, I get 4x plus 5. So 3x minus 2 into 4x plus 5 is equal to 0. Which implies that either 3x minus 2 is equal to 0 or 4x plus 5 is equal to 0. Which means 3x is equal to 2. So x is equal to 2 by 3. Or 4x is equal to minus 5. And so x will be equal to minus 5 by 4. These two are the solutions for the given equation, that is 12x square is equal to ax minus b, in which we substituted the values of a and b. So now let's move on to the next question. In the next question, it says use the substitution y is equal to 2x plus 3 to solve for x. If you remember earlier in this exercise where we had a little bit of a complex term in the squared, we were taking it as a different variable since these two were same. Now the question itself is asking us to do that substitution. So since y is equal to 2x plus 3, wherever we see 2x plus 3, we will replace it by y. Which means the new equation formed is 4y square minus y minus 14 is equal to 0. So now I have to solve this quadratic equation for y. Once we get the value of y, we'll substitute back to 2x plus 3. Then we'll find the value of x. So now we have 4 into minus 14, which will be equal to minus 56, and I have to solve this. So I get 4y square minus 8y, 7y minus 14 is equal to 0. Since minus 8 plus 7 is minus y, and minus 8 into plus 7 is minus 56. So here I take 4y as common, I get y minus 2. And here I take 7 as common, I get y minus 2 again. It becomes 4y plus 7 into y minus 2 is equal to 0. So either 4y plus 7 is equal to 0 or y minus 2 is equal to 0. Which means y is equal to minus 7 by 3, minus 7 by 4, or y is equal to 2. But that is not the end of the question. Remember, we substituted y as a value for something, that is 2x plus 3. So now instead of y in both places, we will write 2x plus 3 is equal to minus 7 by 4, or 2x plus 3 is equal to 2. For this we will get 2x is equal to minus 7 by 4 minus 3. Yeah, so one value of x will be minus 9 by 8, minus 19 by 8. See what I did, I took minus 3 to the other side, taking the LCM as 4, I got minus 12, so minus 7 minus 12 is minus 19. And then I took 2 to the other side, it became x is equal to minus 19 by 8. Or 2x will be equal to minus 1, since 3 goes that becomes minus, and x will be equal to minus 1 by 2. So these are the solutions for the given equation, that is 4 into 2x plus 3 whole squared minus 2x plus 3 minus 14 is equal to 0. So now moving on to the next question. The next question says, without solving the equation 6x square minus x minus 2 is equal to 0, find whether 2 by 3 is a solution. So in this question we have to go back to our basics that we learnt in the beginning of the lesson. That is, what is a quadratic equation? And if you don't know this, that means you haven't watched the conceptual part video of the chapter. So please go to our channel in the description down below, follow us, subscribe, and turn on the notifications. Apart from that, watch Quadratic Equations part 1, that is the conceptual video. From that, you'll get an idea of everything that we are going to cover in this video. So, our basics said that a solution is any value that satisfies any given equation, not only for quadratic, linears, cubics, any type of equations. A solution would be something that satisfies that equation. So, to see whether it is a solution, what we are going to do is we are going to substitute this value into this equation wherever you see x, and if the sum or the product or whatever it is actually equal to 0, we can say that the equation is satisfied, and hence 2 by 3 will be a solution. Let's try. So if x is equal to 2 by 3, we'll substitute 2 by 3 everywhere in this equation. We'll get 6 into 2 by 3 whole squared minus 2 by 3 minus 2. And we'll check whether it is equal to the right hand side, which is 0. So 6 into 4 by 9 minus 2 by 3 minus 2. This becomes 2 by 3. 2 into 4 is 8 by 3 minus 2 by 3 minus 2. Clearly the LCM is 3. So then I equate with 3. I get 8 minus 2 into 3 will become minus 6. Now 8 minus 2 minus 6 is 8. So it will become 0 by 3 is equal to 0, which is equal to our right hand side of the equation. Hence, we can say that since LHS is equal to the RHS, 2 by 3 is a solution for said quadratic equation 6x square minus x minus 2. Okay. Now, let's move on to the next question. Next, we have determine whether x is equal to minus 1 is the root of x square minus 3x plus 2. Like the earlier question, this is the same. We have to substitute the value of x in this particular quadratic equation and check if it is actually equal to, when we substitute, if this side is actually equal to 0. If it is, we can say that minus 1 is a root. Let's try. So it's given that x is equal to minus 1. So instead of minus x, I am going to write minus 1. So minus 1 squared will become 1 and minus will become plus 3 plus 2, which we clearly know is equal to 6, which is not equal to the right hand side, from which we can conclude that minus 1 is not a solution. Okay, so let's move on to the next question. Now in the next question it says if x is equal to 2 by 3 is a solution of the equation, this equation, find m. Here the logic changes a bit, but it's not very different. Earlier we were checking whether it was a solution. Here it is given to us that this value is a solution, which means it should satisfy this given equation. So what is our job here? So if you look closely at this equation, it has two variables. It has x and it has another variable m, which is the coefficient of the single degree x term. Substituting 2 by 3 into this equation, it will satisfy that it is equal to 0, and from there we are supposed to find the value of m. Let's try. So since it is given that x is equal to 2 by 3, the first process is same. We substitute 2 by 3 into this equation wherever we see x. So 2 by 3 whole squared plus m into 2 by 3 minus 3 is equal to 0. See, earlier I wasn't writing this equal to 0 because I was supposed to check whether it was satisfying the equation. In that case, I had to check the LHS and then equate it to the RHS. But here it is given that it's a solution, so it will be equal to 0. So anyways, this is 28 by 9 plus 2m by 3 minus 3 is equal to 0. So the LCM here is 9, right? So when I take 9, I get 28 plus 3 into 3, that will be 6m. Since this is 1, this becomes minus 27 is equal to 0. I take 9 to the other side. See, clearly 28 minus 27 is 1. So 1 plus 6m is equal to 0 because 9 into 0 is 0. So 6m will be equal to minus 1. M will be equal to minus 1 by 6. So given that 2 by 3 was a solution, we substituted it into the equation and then we found the value of m to be minus 1 by 6. Moving on further. So in this next question, it says that x is equal to minus 3 and x is equal to 2 by 3 are solutions of the given equation mx square plus 7x plus n is equal to 0. Based on that, we are supposed to find the values of m and n. Like the earlier question, instead of 1, now we have 2 solutions. But again, the difficulty arises because there are 2 other variables in the equation as well. You know that x is our base variable because that is what the equation depends on. Then we have m, which is the coefficient of x squared, and n, which is the constant. So we are supposed to find the values of m and n based off of these solutions. You may have learned this method in your school or somewhere else. That first we'll substitute minus 3 into this equation. We'll get a linear equation in 2 variables in m and n. Then again we'll solve putting 2 by 3 into x. Then again we'll get another linear equation and we'll solve them simultaneously. However, I am going to teach you a way which may be a bit easier for you. Remember how we formed quadratic equation given on solution sets? So here we have a solution set that is minus 3 and 2 by 3, which means we can form a quadratic equation right off of here. We don't even need this for right now. I'll show you. So x is equal to minus 3 or x is equal to 2 by 3, which means x plus 3 is equal to 0 and 3x minus 2 is equal to 0, right? I bring 3 and bring 2. So which means that x plus 3 into 3x minus 2 will be equal to 0. So the equation comes out to be 3x squared minus 2x plus 9x minus 6 is equal to 0. 3x squared plus 7x minus 6 is equal to 0. Now this is our given equation based off the solutions. But it also says that these are solutions for this equation, which means that this and this equation should be the same. Let's try and compare them. We have 3x squared plus 7x minus 6 is equal to 0. And then we have mx squared plus 7x plus n is equal to 0. Clearly we have 7x, so we are on the right track. Now we'll compare the coefficients of the x squared, which means m is equal to 3. And similarly, we'll compare the coefficients, which means n is not equal to 6. Since the sign is plus, I can write this as plus and put it in a bracket. We'll get that n is equal to minus 6. I don't know if you agree with me or not, but this is rather a simpler way because you don't need to get confused with solving two linear equations simultaneously. So what we will do is, using these solutions, like we learnt, we'll form a quadratic equation. Then we'll compare it to the equation given to us, and the coefficients we will divide out, and that's how we find the values of the separate variables m and n in the given equation. Now let's move on to the next question. The next question is kind of similar. Here it says that if quadratic equation so and so has one root as x is equal to 3, we are supposed to find the value of m, which is obvious like the other question, but here we are also supposed to find the other root of the equation. So first things first, it's given x is equal to 3. So we substitute this value of 3 into this equation wherever we see it. We say 3 square minus m plus 1 into 3 plus 6 is equal to 0. So 9 minus 3m minus 3 plus 6 is equal to 0. 3m will be equal to 9 minus 6 is 12. So m will be equal to 4. Now we substitute m back into this equation, we get x squared minus 4 plus 1 x plus 6 is equal to 0, which is x squared minus 5x plus 6 is equal to 0. So now we are going to solve this equation by factorization. So if you didn't understand till here, it was given that x is equal to 3 is the solution of this given equation. We substituted that to find the value of m, but that is only half the part of the problem. Now the next we have to find the other root. We know x is equal to 3 is 1, we have to find the other root. So now I split minus 5 in such a way that its addition gives us minus 5 as the coefficient and the product gives us plus 6. So I write 3x minus 2x plus 6 is equal to 0. Since minus 2 into minus 3 will be equal to plus 6. So x into x minus 3, and if I take minus 2 as common, I get x minus 3 again. X minus 2, x minus 3 is equal to 0, which means x is equal to 2 or x is equal to 3. Since we knew that x is equal to 3 is a solution, now we have x is equal to 2 is the other solution of this given quadratic equation. So now let's move on to the next question. So in the next question, we have given that 2 is the root of the equation 3x square minus bx plus 10 is equal to 0, and that the equation px square minus qx plus 9 is 0 has equal roots. Find p and q. Now here we have to employ two different logics. First, like the earlier problem, we have one root of this equation which has one extra variable. We have to find the value of that variable. Then we have to substitute p here in this equation and then find the value of q based off of the fact that this equation in px square minus qx plus 9 is equal to 0 has equal roots. And if you may remember, in equal roots the discriminant is equal to 0. If you don't know why that is, which means you haven't watched Quadratic Equations, the conceptual video, that is the one in where we learnt all the concepts dealing with quadratic equations. So please subscribe to our channel, go to our videos list and watch that video. Apart from that, turn the bell notifications on, since we have faculties who teach very well subjects such as SST, chemistry, bio, physics and maths as well. So please stay tuned to our channel. Now coming back to our problem. So the first part, it is given that x is equal to 2. Now we substitute that in this equation. We get 3 into 2 squared minus p into 2 plus 10 is equal to 0. Which gives us 3 into 4 is 12 minus 12p is equal to 0. So we get 12p is equal to 12, which gives us p is equal to 1. Now since we got that p is 1, we'll just right away substitute it in this equation. We'll get x squared, since p is 1, minus qx plus 9 is equal to 0. For this equation, it is given to us that the discriminant is 0. It's not given, that is not what's given, but it's given equal roots, which means that the discriminant is 0. From this equation, first we'll write that a is 1, b is equal to minus q, c is equal to 9. From here, we know that the discriminant is equal to 0 as the roots are equal. We know that d is equal to b square minus 4ac. So let's substitute that. So we get, since it is 0, 0 is equal to b, which is minus q. So minus q squared minus 4 into a into c, which is 9. So q squared minus 36 is equal to 0, which means q squared is equal to 36. Now we know that 36 is the square of 6. So we can say that q is equal to the square root of 6 squared, which means q will be equal to either positive or negative 6. So this is how we found the value of p first, then we found the value of q. So let's move on to the next question. The next question on first reading may seem a bit complex. As you can see, it's in many variables. It has x, a and b. But trust me, the solution is quite simple if you know how to follow on. First things first, as you can see, the denominator on this side of the equation is ax. And if you can clearly see, here it is a and here it is x, and if we take the LCM, it will also come to ax. And that way, we can cancel out the x and we'll have something less to worry about. So let's go about that. As I said, on this side of the equation, we will take the LCM, which will be ax. So x will be multiplied by x, and a plus b will be multiplied by a, which will be equal to b into a plus b by ax. Now since ax and ax are similar, if we take it to the upstairs, it will get cancelled, so we'll cancel it out directly. We'll get x squared minus a square minus ab is equal to ab plus b squared. This part of the equation we'll take to the other side. So we'll get x squared is equal to ab plus b square, and since these both go to the other side and become positive, it becomes plus ab plus a square, which is a square plus 2ab plus b square. What does this look like? If you can go back to 6th or 7th mathematics, this is the expansion of a plus b whole squared. So we'll write x squared is equal to a plus b whole squared. Clearly, because it's a square plus b square plus twice of a into b. So again, we'll write that x is equal to the root of a plus b whole squared, from which you get that x is equal to either positive or negative a plus b. So this will be the solution of the given quadratic equation. Now let's move on to the next question. The next question is 1200 by x plus 2 into x minus 10 minus 1200 is equal to 60. So the numbers may be huge, but don't worry. The process is very much similar. First things first, what we'll do is we'll take this 1200 to the other side. We get 1200 by x plus 2 into x minus 10 is equal to 1260. Here what we are going to do in this bracket, we'll take 2 common. So if we take 2 common, we get 600 by x plus 1 into x minus 10 is equal to 1260. And when I divide that by 2, I get 630. So it will become 600 plus x by x into x minus 10 is equal to 630. Taking this x to the other side, I get 600 plus x into x minus 10 is equal to 630x. Now when I multiply this, I get 600x minus 6000 plus x squared minus 10x is equal to 630x. When I bring all the terms to any one side, I will get x squared minus 40x minus 6000 is equal to 0. So this is our quadratic equation. This is what we are supposed to solve. So now I have to split minus 40 in such a way that its sum is equal to minus 40, the coefficients, and the product is equal to minus 6000. So we have x squared plus 60,000. So 100 minus 60, the coefficients will be equal to minus, sorry, the sign's wrong. When I do minus 100 plus 60x, I'll get minus 40x. And if I multiply them, I'll get minus 6000. So I take x as common, it x minus 100. Here I take 60 as common, again I get x minus 100 is equal to 0. So x plus 60 or x minus 100 is equal to 0. Which means x is either equal to minus 60 or x is equal to 100. And these are the solutions for our given equation. Now let's move on to the next question. So in this question we have, if minus 1 and 3 are the roots of x square plus px plus q is equal to 0, find the values of p and q. And here again we are going to solve it by forming our own quadratic equation based off of these roots, then comparing it to the given equation. So, it's given x is equal to minus 1 or x is equal to 3. From this you get x minus 1 is equal to 0 or x minus, plus 1 is equal to 0 or x minus 3 is equal to 0. So, we multiply them. Get x plus 1 into x minus 3 is equal to 0, which is x squared minus 3x plus x minus 3. X squared minus 3 minus 2x minus 3 is equal to 0. So now we have a quadratic equation based off of the roots given to us. So now we'll compare it to this. So we write down our equation, which is x squared minus 2x minus 3 is equal to 0. Or I want to write it a bit more creatively, right? And we compare it to x squared plus px plus q is equal to 0. We see that the coefficients here are 1 and 1. So minus 2, p will be equal to minus 2 and q will be equal to minus 3. And that is how we find the values of p and q. So students, this is the end of today's lesson. But do not worry, the second part of quadratic equations exercise solving, that is exercises 5D, E and F, will be bringing to you very soon. So stay tuned to our channel, subscribe to Midha Guru and join the family today. Until then, keep studying hard and I'll see you in the next one. Namaste.